In these next few lessons, we're going to see how we can fine-tune a model based on our own dataset. Our goal is to create a model that can take a piece of text as the input and determine the emotion of the text and return this emotion label for us. To do this, we'll be fine-tuning an XLNet model. We have a labeled dataset of a number of different sentences and their emotion label. We'll be providing this to the model so that it can learn these associations from our data. We'll then have a custom, fine-tuned language model of our own. So let's get started. The first thing we'll want to do is import the packages and functions that we need, so you can see the list that we'll need for the next few lessons here. We have the pandas package, NumPy, clean text, RE. From the transformers, we'll be importing the XLNet tokenizer, the XLNet for sequence classification, the training arguments, the trainer, and pipeline. We'll also import torch, and from sklearn we want to import train test split and the label encoder. We'll also need the datasets, evaluate, and random packages. So the first thing we want to do before we move on to any kind of language modeling is pre-processing our data. So let's load in our data first. We want to load in data train, data test, and data val. Let's then run datatrain.head to see what our data looks like. And yes, you can see we have a piece of text and an associated label. Let's concatenate the train, test, and validation sets together for now so that we can clean them up all in one go. So we'll use pd.concat over data train, data test, and data val, and ignore index equals true. We can then see we have some emojis in the text. We want to remove these. So we'll create a new column, text clean, and then we'll use the clean function over each of the pieces of text in our data set. We'll specify no emoji equals true to remove the emojis from this text. We also want to remove any punctuation from this text. So again, we'll update our data clean column, and then we'll use re.sub to remove any punctuation from this text. We can check this as work by running data.head. And yes, we can see emojis have been removed and most of the punctuation has been taken out. There is some still left in there, so if you'd like, you are more than welcome to try and update the re sub function to remove any extra punctuation. Let's now look to the labels. We can print these out to check how many pieces of text we have associated with each of the labels. We'll take the label column and then do the value counts and plot it as a bar chart. So you can see we've got 4 emotion classifications here: fear, anger, joy, and sadness. We can also see this is an unbalanced data set. We have a lot more occurrences of text with the label fear compared to sadness. So we want to make sure we have an equal number of pieces of text for each of our labels. So the first thing we can do is take our data and group it by the label. We then want to create a new data frame. And from this, we're going to sample based on the size of the number of rows in the labels. We'll take the minimum, and then we'll reset the index, where drop equals true. Essentially what this is doing is taking our data frame, grouping it by the label, finding the group with the least number of rows, so in this case that would be sadness, and then using that minimum value to sample from all the other labels. We can check this has worked by reprinting our chart. So data label column dot value counts, and then we plot a bar chart, and we can see we now have an equal number of rows per each label. We also want to convert our labels into an integer, so we can use label encoder dot fit transform over our label column. We also want to specify the number of labels as 4, as we'll need to reference this later. The final step in pre-processing our text is creating the training and test data. So first we'll create our train split and our test split using the train test split function from sklearn. We also want to create a validation set, so we'll split our training data set again and put aside 10% for the validation. Let's then print out the lengths to see how many rows we have in each of our splits. So we can see most of our data is going to training, some of it to testing, and then we've left a small sample for validation. We then want to format our data into a dataset dictionary. We also want to remove any columns that we aren't going to be using. So first let's create our train DF. We'll create it as a new pandas data frame with the column label, which takes our integer values for our labels, and a column text, which takes our cleaned up text. We can also do the same for our test DF. So from our test dataset, we'll be taking the label integers and our clean text. We then want to format these into a dataset dictionary. So first we'll take our train DF and run datasets.dataset from dict and our train DF. We'll then do the same with the test DF. And from here we can create our dataset dict. We'll run datasets.datasetDict. And our train will be our train DF, and our test DF. Let's print this out just to check it's in the right format. Perfect, so we have our dataset dictionary split into train and test, both with the features label and text. We're now ready to create our embeddings.